Hello students of Menominee Falls High School. This video is to help you with empirical formula. If everything has gone as planned, your teacher has assigned this to you to complete over the weekend. The problems will be due in the near future. So this is number 1 on that assignment. And the assignment, you can read the assignment for yourself, but barium is 58.84%, sulfur is 13.74%, and oxygen is 27.43%. First thing I'm going to do in this problem is assume that the sample is a 100 gram sample, because that just makes converting these percents into grams very simple. All I have to do is change the unit. So I'm starting with these amounts of grams, and we are focused on conversions, so I'm going to use the factor label method to do my conversions. So I'm just going to pull in that factor label method t-table in for each of them. The other thing that I'm going to need is to make sure that I know some equivalencies to go from grams to moles. And to convert from grams to moles, you'll need the periodic table. In the first problem that I have, I'm looking at barium. So the conversion factor for barium is 137.33 grams is equal to 1 mole. So 137.33 grams is equal to 1 mole. Once I know that that's the equivalent forms, I need to put them into the t-table in the right order. So the question is always, does the 137 go on the top, or does it go on the bottom? And we always write it in so that the units cancel. Grams will cancel grams, barium will cancel barium. Therefore, 1 mole will go on the top. If I were to do that math and figure out what it is equal to, it is equal to this number right here, which is 0.4284. The next conversion I'm doing is from sulfur, grams to moles. To go from grams to moles for sulfur, it is 32.06. So there are 32.06 grams in 1 mole of sulfur. Again, need to make sure that I write them into the table in the right order. Since grams are on the top here, my grams of sulfur must be on the bottom. Moles of sulfur will go on the top. And if I wanted to figure out what that is equal to, that is equal to that number right there. The last conversion is for oxygen. So to find the conversion factor for oxygen, I'm going to look at the periodic table. There are 15.999 grams of oxygen in 1 mole of oxygen. So those two things are equal to one another. 15.999 grams is equal to 1 mole of oxygen. Again, putting them into the table in the right order. The grams has to go on the bottom so that units cancel. And this is equal to 1.715. Sometimes when you're looking at these three numbers, it's very, very easy to see how they fit together and how they're equivalent to one another. If you're having a hard time seeing how one of them is equivalent to another one, the best thing that you could do is just take whatever the smallest value is, which in this case is the top one, and take that top value and just figure out a little ratio. Do the smallest number divided by the smallest number, and take that smallest number and divide it into all of the others. This divided by this happens to work out to be 1. This number divided by this number is really, really, really close to 1. And the top number here divided by the bottom number actually works out to be pretty close to 4. Like I said, sometimes you can just look at that and see, oh, this number is 4 times bigger than that one. Therefore, when I'm writing the empirical formula, it's barium 1, sulfur 1, oxygen 4. So it would look a little something like that when I was all done. You actually do not need to have the ones there, so technically you would probably want to write it like that. It's not necessarily wrong to have the ones there, but nobody would really truly write the ones there. Now that we've done this example problem, for homework, you should take a look at this problem. It's very similar to the example problem that I just did. You can pause the video so you can see the problem. You could even go back to the example problem if you wanted to see how I did that one. And give this one your best shot.